can we develop something less usage of resources, but then effectively putting it into a most interpretable object in front of us, what we are intending to do. That's optimal development. And then faster iterations. The essence of prototyping is to faster iterate of the product that you're thinking, so that it's immediately you could pull in some insights and suggestions and reflect on the product. Okay, that's faster iterations. Now, if I am intending to develop this kind of mouse, when I say prototyping, I could immediately reflect that this mouse by not just integrating, waiting to integrate the electronics part of it and the firmware part of it, but then immediately I would try to prototype it. When I say prototyping, try to bring that into a reality or manifest into a physical form through any kind of medium, which could immediately bring me that sense. That's the lean prototyping. Now we'll see what stage, how do you identify what stage are you at, and if you're at a problem level. When I say problem level, we may not directly know how do we solve the issue, but then we know that there is a pain point, right? That there is a pain point. We don't know how we resolve that issue. And then idea, that's problem. And then idea and explorations. Now we know the pain point, your thought process. How do, for example, I'm telling you, pulling from the previous session, the problem could be, how do you express a thought using what medium is a problem. Now, idea is through a pen. I know that the tool is a pen to express thoughts or to communicate. That's idea. Having a pen is an idea. Having to express a thought is a problem. So now you're going to interpret, go back and think of what stage are we at in terms of problem, okay, and idea. The second thing is pooling adequate insights and information from session 1 and session 2 that we have learned in understanding and understanding the problem much better way through certain activities and activities. You pool all of them. Now emulate is also the similar way. Emulate is like recreating a scenario using available resources. I'll talk about that. Okay, emulate, integrate features, concepts. How? We'll also talk about how do we do it, like quick prototyping, faster prototyping using through different segments like hardware, software, mechanisms design. And how do you create a proof of concept and visualize your better visualize a product using industrial design elements. Until as you fire up your neurons, you won't be able to think of better ideas. That's the reason you prototype. Now there are other obvious reasons that why you need to develop a prototype. If you intend to develop directly a product, you won't have the flexibility in changing. So that's flexibility in design. Over the period, you could alter, add, modify, deduct, anything that you could do while prototyping. And of course, you could also identify errors immediately. Let's say if I'm maintaining a temperature, function or feature of a water bottle, of this water bottle is to, if I'm prototyping this one, like with a thermocol or anything else as such, which replicates the form of it, but not the main function. Developing the thermocol model, and then now what you could do, check in that form is that whether am I doing it right? The form is right or no? Or can I alter any shape profile of it so that it doesn't slip from hand? Okay, those kind of features also very quite important. The main principle of this water bottle, I'm not fiddling with it. Okay, the main principle is intact. Okay, the steel and the vacuum thing, that the technology of the water bottle is intact. But then what we are trying to explore is, while doing prototyping, is other features and functionalities of ID elements. Let's say usability, ergonomics of it. That's what we're going to explore in prototyping also, which directly may not sound obvious but evident. Subtle differences, subtle cues, attributes, we will alter. So you will see the functionalities. As I was saying, the usability is one functionality that you're going to check in prototyping, add, modify. Scope for refinement. Every time you do, you'll get a new thought or an idea, right? That's very much sure. Like, you cannot keep continuing in thinking process, but at least reflect immediately in one physical form so that you can refine better. Of course, you can draw great insights, suggestions. Until unless I make a water bottle like this, I cannot reflect physicality to it. Okay, I can draw it and then show it to people, but then the texture, the physicality, the sense of it might not be reflected. So that's the reason you prototype also. Okay. Drawing insight suggestions, effective in communicating an idea. This we have seen in while we are visiting to clientele. Okay. Effective way in communicating an idea is we propose them an idea. If you want to create a better mouse, okay, or a better mouse and interaction with the system, if you go to the client and then we tell them, hey, you know what, we're going to develop a particular system by which you can interact with your system, okay, where there is no physicality to it, okay. There is no object you are interacting like just like mouse, but there is nothing using gestures you can interact with your system. This sounds okay and fascinating, but then client might not get a trust, confidence, or get overwhelmed by mere hearing. But then if you try to prototype it, let's say you hide the mouse back of you and then drag or do something, then there could be something, there's some level of an excitement. And how do we do that? Like, there is nothing I could see. There is nothing that I'm able to see in front of me, but then it's still happening. Meaning there's some magic beneath it. So that's the reason it's very important for us to create a prototype, and it'll ignite anyone's mind in conveying the idea. Integration requirements are very well understood. Once I create a form to it, then I'll understand, should I put a grip for the model for a better holding. And as such requirements after integration of prototyping only we'll get to know. Creating an interactive tool with the system is not right away excited to the clientele, but then if you create a prototype, then he'll be excited, right? So that's like invoking stakeholders. The client is a stakeholder, right, in the whole business viability. Then you're actively involving him also so that you can draw his insights. There is one product development for us, which is into oncology, colposcopy development, which for many of us who does another colposcopy is an instrument to visualize the cervical cancer. Initially, we are clueless and slightly directionless. Okay, where do we even start? Okay. However, we know the design processes that you need to start from design thinking and understand the problem, insights, just follow the user, be with the people, stakeholders, and all that we know. Okay, session 1 and session 2, the things that I've mentioned. Let's create a scenario. Now, without if you have to prototype it, it's not right away. You cannot recreate a colposcopy instrument and then create it. Now, without, let's say, okay, very simple technique which we used to get a sense of how it's going to be. Okay, there is a technique, emulate, I was mentioning, recreate here, user scenario with accessible resources. In the session, in the earlier, I've shown quite a lot of resources which are available and accessible for us to emulate. Having seen this problem, oncology is such sophisticated medical problem that we're about to, that we're about to deal. This is emulation. You emulate however sophisticated is the problem, okay, with the available resources. Now it's very tough for some of us to really think or metaphorically create a scenario using available resources. There is a pen stand, okay, which acts like a colposcopy instrument, and the doctor does the procedures with the hand. The instrument is at the middle of the patient and the doctor. Okay, now this is a thing which the user scenario that we want to replicate it. Fortunately, the team member is so creative in emulating with available resources, keeping this at the center of the pen stand at the center, and then there is the hole in the lamp, which is through that is a microscope that feature in a colposcopy. He's replicated it. So that's emulate. Now you get a sense and gist of how the user scenario is and how the colposcope is. This is done in 2 minutes, right? To your right resources to replicate it, hitting to your right resources. Okay, 2 minutes it has taken for us to replicate a colposcopy user scenario, emulate. Now, after looking at this, we have drawn beautiful insights, like suggestions or insights, recommendations from the experience of colposcopy. Okay, so if I'm doing like this, there is an instrument in between. How feasible for me to do certain activity? That instrument in between. That the team, what the guy was doing is it possible for me to draw something, or is it possible for me to write something when there is an instrument in between me? right? These are the simple questions where you can reflect immediately using available resources. That's why Emulate is so powerful tool. Now you're going to see integrating features one by one, okay, before even you create a proof of concept, okay. When I say proof of concept, okay, I'll talk about it, but then integrating features one by one. If you remember, earlier I was mentioning the product that we developed in urology, urine collection bag, okay. Now urine collection bag for ostomy patients is tough problem for at least to immediately to attain a solution, because urine collection bags are there ever since few decades. They're there. Now how do we create a better product in urine collection bag? If I trying to answer this question of how do we create a better bag, I may not hit to a right solution effectively. Now what do we do? Simply add features in prototyping. Now I'm not creating solution for the problem of how do we create a better bag, but then what I'm trying to do is mimicking the existing feature of a urine collection bag. Okay, now I know that urine collection bag is there, that is to collect urine into the pouch. A simple feature, right? Okay, so now what we did is we have taken a plastic bag and then put some water into it in a level form. So one feature of the bag is to collect urine. We did it. So after you do it as such a simple activity, now you want to understand certain elements or subtle attributes to refine effectively. That's what we did. Now ultimately, after certain iterations, the end product and conceptualization that we have did, this is the end product of a urine collection bag that we have seen in earlier also, but I'm trying to show how effectively can we do using baby steps. Urine collection bag, you might directly try doing it, but then you cannot draw beautiful insights unless you prototype in a baby steps format. However complicated is a problem, however simpler is a problem, what you need to do is break down into certain categories that you could achieve a milestone with. Attaining a feature is one milestone, second feature, third feature. Now all the features are done. Now go back, now go forward in thinking, how do we concise or comprehend or create a beauty to the product? Okay, that we'll talk about it, but then one feature addition is done. After you give features, now we know what features work. Now that you have attained all the features individually, proof of concept is something all of us know that if you add all the features and functionalities of a product into certain element or rudimentary format is what proof of concept is. I partially agree to it, because it's not of adding all the features and functionalities, but then you need to pick up right funda of the problem, right brief, right intent of the problem, and solve that. Okay, now using that proof of concept of a model, nobody in the stakeholders should be denying the fact of its functioning. Now what we have promised of urine collection bag is collect urine into the pouch, check, done. And volumetric measurement of the pouch, check, done. These two. Now how usable is the product is secondary, but then fundamentally these two are the intent of the product, which earlier also products are doing. Urine collection, earlier products are also doing. One USP is volumetric measurement that we did. Okay, no, there is none to question on the functional and the usability factors of it. Of course, we're going to work out, but then achieving this is proof of concept and a milestone. Okay, now you'll get some industrial design elements of what I'm trying to focus here, right? Until this point is features and functionalities to be solved. Okay, then you go forward and then see how these ID elements work, visualization. Now you're gonna say, okay, now that this feature is working, this functionality is working, how is this usable? Can we alter something? Okay, can we alter a little bit so that this is more usable by the patient? However, you have solved the main principle of the product. That's a usability factor that you talk about. And ergonomic considerations. While I'm wearing this, is it really ergonomic? Okay, that's what you see in ergonomic consideration. And then styling, sketching. Now, after ergonomic considerations, what you do is probably think about, let's say, if it is a competitive product or there is most competition in the particular segment, you need to create a subtle discrete difference between the competition, what you do is create a style which talks about which stands you makes you to stand out of the loop, okay, or the competition. That's styling. You create a motif, you create a some uniqueness, beauty into the language of the product, okay, in terms of color, form, finish, which we're going to see next time. But then styling, sketching, see, sketching is a beautiful tool for some of us who could do it. Sketching is also immediately you could visualize a particular prototype or a product. I will show some of the sketches of how we did it. And then form factor. So form factor is another session that I could talk about, like elaboratively. Form factor, how does form factor affect the visual perception of a user, right? And then mock-up, an instrument which is to be worn on body for example, dehydration monitoring, right? If an instrument needs to be created for dehydration monitoring on the skin, now it could be kept anywhere. There is no constraint of keeping it anywhere. You could put on multiple places. The whole one of the constraints is how firmly is it attached to the body. Okay, dehydration monitoring can be measured anywhere. How firmly is it used? How firmly it is used? That is only the constraint. Now, for that constraint, keeping that as a constraint, now we created a usability ergonomic consideration that the POC is done, the technology explorations are done. Now we are on the next level of creating a usability ergonomic, all the ID elements. So these are certain explorations. How about the only constraint is that keeping it firm? How about we keep it hooked to the NOS so that it is really, that's one possibility, or otherwise strap, something like a watch. Watch is more ubiquitous. There is no style to it. Okay. I mean, that's a lifestyle accessory. This is a medical device. Okay. You are getting it, right? The reason why we do not venture into a lifestyle accessory, that creates a conflict in the mind of the user that it's a medical product and it's a lifestyle accessory. Now, we don't confuse the user, right? So you need to create a discrete difference between the usability or the attribute of a product. So we explored other possibilities of doing it. How about, putting it to the shoulder? How about to the, where all the possibilities? So this is one more tool to visualize. Okay. You have explored the technology, all the explorations are done, okay, to the idea that you want to solve, the problem you want to solve, and then create a proof of concept, and then have seen it. After creating a proof of concept, ID factors are done. Okay, now that you know how it is used, you visualize it. If urine collection bag is to be used, how it is used by the patient. Now it's like a experiment or exercise that we do in a sketch format that we did, but there are other alternatives also. You could either test it physically, since you have created a POC or the prototype, you know how it is, the physical product. You can also wear it and then see. That's visualization, because you get a better sense of product. Either you visualize or experience. Both the things are integrated. Now that after you having a prototype, you experience also.